So today we're going to be looking at rational and irrational values, and we'll also be looking at the number system. So we determined that a rational value is a value that can be represented by a fraction. And an irrational value is a value that cannot be represented by a fraction. So we've been investigating a lot of roots and radicals at this point to determine if it is a rational value or irrational value. So -3/5, since it's already written as a fraction, this is a rational value. For the square root of 14 here, if you were to calculate the square root of 14, it's approximately 165, and it keeps going. So there is no perfect square root of 14. 14 is not a perfectly squared value. And because of the nature of the decimal that it creates when you solve it, this is an irrational value. So I could not write this as a fraction. And then in the case of the cube root of 8/27, this is just the same as the cube root of 8 divided by the cube root of 27, which is 2 divided by 3. And since the solution can be written as a fraction, it is considered a rational value. And there are more values than just rational and irrational. Oops, sorry about that. See if I can get it to go back. There we go. So we looked at the set of real numbers here in grade 10. So starting rational, irrational, we found some of those values on the last page. You could say -4/5 is a rational value. You could say any periodic decimal, like 3.11 continued. You could say a radical, like the cube root of 27 is rational. And irrational values are things like pi. It could be something like 2.613 that goes on. It could be the square root of 70, so on and so forth. And then we have integers, whole numbers, and natural numbers. So integers are values that are negative and positive, so things like -1, 0, 1, 2, and the list goes on. So it's going to include all those negative whole values and all those positive whole values along with 0. Whole numbers are 0, 1, 2, 3, and so on. And then natural numbers are almost the same as whole numbers, except there are no zeros. So things like 1, 2, 3, and so on. And then in this problem here, let me just move this. So it wants us to use a number line to order these values from least to greatest. So a couple options here. You can estimate the values, or you're allowed to plug them into your calculator to find their exact values. So we'll try approximating root 13 and root 18, and then for the rest of them, I'll use the calculator. So the cube root of 13, that's going to sit somewhere between the cube root of 8 and the cube root of 27. So it's going to be a value between 2 and 3, but it's definitely going to be closer to 2 because 13 is closer to 8. So we can approximate that at about 2.3 maybe. For 18, that's going to be between the square root of 16 and the square root of 25, which is between 4 and 5. But again, much closer to 4, so let's say something like 4.2. And then we know the square root of 9 is 3. Using a calculator, I can determine that the fourth root of 27 is 2.28. I'm rounding this decimal here. And that the cube root of -5 is -1.71, approximately when I round. So on a number line, we could put things, since the lowest value I know is -1, maybe I'll start at -2 here, -1, 0, 1, 2, 3, so on and so forth. So I'll just name these A, B, C, and D by color. So let's place that -1.7 about here, I'll call it A. Then I can place the 2.28, maybe I'll call it B. And then 2.3 would be next. So I'll call this one C. And then let's go, sorry, this one's going to be in yellow, so a little harder. D is 3. And then last but not least, I'll just get a different color here, purple. So we'll call this E 4.2.